everyone, and welcome to this explainer on the origins of artificial intelligence. Look, today we're going to look right past all the current hype to really understand the fascinating 70-year cyclical journey of ambition, failure, patient rebuilding, and eventual breakthrough. Our goal here isn't to get bogged down in dense engineering schematics. Instead, we want to clearly understand why AI exists, why it took so incredibly long to mature, and why its sudden arrival in our daily work is absolutely anything but an accident.
So here's our quick roadmap for today's explainer. 1. The birth of AI. 2. Moving from rules to machine learning. 3. The AI winters. And 4. Why generative AI emerged exactly when it did.
All right, let's jump right into section 1, the birth of AI. So back in 1950, the brilliant British mathematician Alan Turing asked a deceptively simple question that kind of changed everything. Can machines think? But, Turing was incredibly pragmatic. He realized pretty quickly that debating what thinking actually means was basically an unanswerable philosophical trap. So he proposed a behavioral test instead, what we now know as the Turing test. He figured if a machine communicating via text could consistently fool a human into believing it was human, well, then for all practical purposes, it was thinking. Turing brilliantly shifted the entire debate from a philosophical puzzle straight into a measurable empirical engineering challenge.
Fast forward 6 years after Turing's paper, a small group of audacious mathematicians gathered at Dartmouth College, and it was here that they literally coined the term artificial intelligence. But unlike Turing, who focused strictly on the outward behavior or the appearance of intelligence, the Dartmouth group wanted to go deeper. They actually wanted to reverse engineer the inner machinery of human thought, stuff like perception, memory, reasoning, and language. It was an incredibly bold, bottom-up approach to recreating human cognition.
Which brings us to Section 2, from rule-based systems to machine learning.
So, for decades, the dominant paradigm was what researchers fondly call good old-fashioned AI, or GOFI for short. The fundamental idea here was that if human experts could articulate their knowledge, you could simply program it as explicit logical rules. Think of basic if-then statements. If the patient has a fever and a sore throat and fatigue, then consider influenza. These were known as expert systems, and they achieved genuine success in specific domains like medical diagnosis. Plus, they were highly transparent. In fields like law or finance, you could audit exactly why the computer made a specific decision because the rules were written right there in the code.
But here's exactly where they hit a wall. I want you to really think about this for a second. How do you write a rule to recognize a cat? A 3-year-old does this effortlessly, right? But if you try to code it, what rules do you even use? Pointy ears, fur, a tail? Good luck writing an explicit if-then statement for an animal that actively ignores you until it's hungry. Every single explicit rule you try to write just dissolves into ambiguities and exceptions. So the crucial takeaway here is that human expertise isn't just a list of explicit rules. So much of what we know is tacit. It's based on intuition, pattern recognition, and unstructured context. The rigid rules of expert systems simply couldn't handle the fuzzy, messy reality of the real world.
And that brings us to a massive, absolute game-changer of a paradigm shift: machine learning. Instead of relying on humans to painstakingly write rigid, pre-programmed logic for every possible scenario, what if we just let the computer learn from experience? With machine learning, you feed the system thousands of examples, say tens of thousands of photos of cats, and the system uses statistical inference to find the patterns all on its own. It was a revolutionary departure from the old way of doing things.
So just to summarize this massive transition, we essentially moved from good old-fashioned AI, which was transparent, sure, but incredibly inflexible and limited by what humans could explicitly articulate, over to machine learning, which is dynamic, statistical, and actually capable of adapting to the messy complexities of real-world data. This statistical approach, that is the true foundation of the AI we use today.
Let's move on to Section 3, the AI winters.
Progress in AI has been an absolute roller coaster. Researchers actually refer to the deep valleys as the AI winters. These were long, brutal stretches, sometimes lasting a decade or more, where public enthusiasm totally collapsed, funding completely dried up, and research effectively went into hibernation. We saw the first major winter in the mid-1970s, and a second massive one starting in the late 1980s. Both of these were driven by a huge gap between inflated public expectations and actual technological reality.
So what specifically caused these massive busts? Well, the first winter was largely triggered by the failure of machine translation. Early developers thought translating Russian to English would be a simple rule-based dictionary swap, but they learned the hard way that language is deeply contextual, cultural, and ambiguous.
Formal rules just failed outright. The second winter happened when the commercial market for expert systems collapsed. Companies had spent millions on highly specialized, very expensive hardware and rule-based systems, only to find them completely inflexible and suddenly outperformed by cheaper, general-purpose desktop computers.
But here is the absolutely crucial thing I want you to take away from our explainer today. The ambitions of those early pioneers were not entirely wrong. Looking back, the AI winters didn't prove the ideas were misplaced, they simply proved the ambition was premature. The intellectual framework was actually largely correct, they just fundamentally lacked the underlying infrastructure to make those dreams reality.
Which perfectly sets up Section 4, why generative AI emerged now. For the longest time, machine learning was primarily analytical, right? It categorized data, it told you if an image was a cat or if an email was spam. But now, we have systems that generate entirely new possibilities out of thin air. They write essays, compose gorgeous images, write functional software code, and hold highly nuanced conversations. This isn't just a minor, incremental update. It's a completely unprecedented capability.
This sudden explosion of capability, it wasn't an accident. It was the result of three massive, long-term infrastructural forces converging at exactly the right time. First up, data. Thanks to the internet, we finally had an unprecedented, staggering volume of digitized human knowledge to act as raw training material. Second, computing power. Specialized processors and massive cloud infrastructure finally gave us the raw calculating grunt required to train models with billions of parameters. And third, a monumental breakthrough in architecture called the transformer, introduced in 2017. The transformer finally allowed machines to understand not just sequences of words, but how meaning and context actually flow through entire paragraphs in complex conversations.
Let's pause and think about why this specific breakthrough actually matters to your daily professional life. Think about it. Human institutions are built entirely on language. A corporation is essentially just a collection of contracts, emails, and strategic plans. A hospital runs on clinical notes and diagnostic guidelines. Law is made of statutes and precedents. Language literally is the operational fabric of human civilization. So when an AI system gains the ability to read, summarize, and generate text with high coherence, it isn't just accessing data anymore. It's integrating itself directly into the very fabric of how we run our institutions.
And the scale and speed of this realization have just been absolutely staggering. When the large language model underlying ChatGPT was released to the public in late 2022, it reached 100 million users in just 2 months. Let that sink in. That is a rate of consumer adoption completely without precedent in human history.
This massive adoption rate signals a definitive inflection point. The trajectory of technology changed so sharply that the old rules simply no longer apply. These previously impossible, basically science fiction level capabilities didn't just emerge, they suddenly became an urgent, totally unavoidable reality for every single organization and professional on the planet.
And that leaves us with a pretty profound question as we wrap up today's explainer. If language is the operating system of business, and machines can now fluently navigate that system, when a machine masters the operational fabric of human civilization, what does that mean for the future of skilled work? It's a massive, massive shift, and understanding the history we just went through is the very first step to navigating what comes next. Thank you so much for joining me for this explainer, and I really encourage you to keep exploring the realities of this incredible technological evolution.